Hello, today I'm looking at M3 International A-Level, May 2014. This is question 7. So I have a uniform right circular solid cylinder, has radius 3a and height 2a. A right circular cone of height 3a over 2 and base radius 2 is removed from the cylinder to form a solid S, as shown in figure 4. The plane face of the cone, so this flat area here, coincides with the upper plane face of the cylinder, and the centre O of the plane face of the cone is also the centre of the upper plane face of the cylinder. So in other words, you have an axis of symmetry vertically through O. Part A asks you to show that the distance of the centre of mass of the solid from O is this, and this is worth 5 marks. So for this kind of question, I need to make a little table, and I'll do the cylinder minus the cone makes a funny thing. Whoops, sorry, it's a oh, sorry, terrible drawing, doesn't look anything like it, never mind. There we are, right, okay. And so this is S. So first line, I need to do the ratio of the masses. So here I need to use something that is proportional to the mass, and as this is a solid, then I can use the volume. So the volume of a cylinder, the formula is pi r squared h, so I'll do pi times the radius squared, the radius is 3a, so I end up with 9a squared, multiplied by the height, which is 2a. For the cone, I use pi over 3 times r squared h. The radius is 2a, so if I square that, I end up with 4a squared, times by the height of the cone, which is 3a over 2. Then to find out what goes here, I could do this minus this, but because I am using the ratio, what I could do is simplify these first. I need to be very, very careful because a mistake at this stage will be terrible for your accuracy marks throughout the rest of the question. But if I'm very, very careful, I can do it. So let's see what I can cancel. Both of these can be divided by pi. Both of these can be divided by a cubed. Here I've got a 3 and a 3. A 3 on the top and a 3 on the bottom that will cancel with each other. Here I've got a 4 and a 2, so that will cancel and give me a 2. And in fact I've got a 2 here and a 2 here, so those will cancel with each other, and I'll be left with a 1 there. So the ratio of masses is 9, 1, and here I need to do 9 subtract 1 to give me 8. So the ratio of the masses is 9 to 1 to 8. Then I'll do the distance of the centre of mass from O of each of these objects. So for the cylinder, it's halfway down the height, so half of 2a is a. For the cone, the formula in the formula book is it's a quarter of the height from the plane face, so I need to do 1/4 multiplied by the height, 3a over 2. And for this one, I can call it whatever I like, X bar or Y bar or something like that. And now I'm ready to take moments. So I'll do this times this minus this times this equals this times this. So I end up with 9a minus, here I end up with 3a over 8 equals 8y bar. And so here I end up with something a. So I can do 9 minus 3/8. And then divide it by 8. And so I get 69 over 64, which fortunately is what they said the answer should be, as required. Phew! So that is your first 5 marks. The question then goes on to say, point A is on the open face of S such that OA is 3A, as shown in figure 4. So if I look back at the figure, I can see there's this place here that they called A, and they said OA is 3A, so I can see they're just talking about the radius there. So A is on the outer circle here. the solid is now suspended from A and hangs freely in equilibrium. So it would be a good idea for me to try to draw a simple picture of this looking from the side, and then I can draw in the vertical. And I know that if this object is suspended from A, then the vertical will go through where the centre of mass of the object is. So part B, so I have the height, I have the centre of the shape there, here's A, I've got the cone which is here, which I don't really care about where that is actually now, but I do know that Y bar is going to come somewhere here. So this distance that I just worked out was Y bar. I know that this length here is 3A, and I know that the vertical will go here. And I just need to be very careful to see what they asked. Find the angle between OA and the horizontal. Now, very often they ask, so O was there, so OA and the vertical is here, so therefore OA and the horizontal will be at 90 degrees to that. So they basically want this angle here. Now, this angle here, if this is the horizontal, is 90 minus this angle here, and then in this triangle, this and this angle will add up to 90, so therefore this one here, that is the angle they're looking for, is equal to this angle here. So I'll call that theta, and I can see that theta is inverse tan of opposite over adjacent, so 3A over what I worked out to be Y bar. So I can do inverse tan of 3A divided by this. So I've got 3A divided by 69A, and then I would have an over 24, which would flip up to the top. So I end up with a 64 on the top. Here the A's cancel, so I end up with 3 lots of 64 on the top, so 192 divided by 69. So I get 64 over 23, but I just need to do inverse tan of that. So the angle is 70 degrees to the nearest degree, or you could write 70.2. They didn't specify the accuracy here, so either of those answers would be okay. So that is for 3 marks. Then in the last part of the question, it says the solid is now placed on a rough inclined plane, rough meaning that there will be friction, with the face through A in contact with the inclined plane. So I can see that they've put A there. Then the solid rests in equilibrium on this plane. The coefficient of friction between the plane and S is 0.6, and the plane is inclined at an angle of thigh to the horizontal. That's there. Given that S is on the point of sliding down the plane, show that this angle is 31 degrees, presumably, to 2 significant figures. Ah, yes, it's degrees, it tells you there. Okay, so now, okay, so what is the situation here? I should perhaps draw a diagram and draw the forces. So here, let's just draw the plane with this angle that they were talking about there. So because this is a show that question, I need to make sure that I don't put a value in for this angle, and what I'm trying to do is just find this angle and hopefully it will come out to this. So remember, on a show that question you can never use the thing that you're trying to show. So what will happen? Well, I'll just draw this as a particle. I would have the weight of it here, and I don't know what the mass of it is, but I'll just call it M. And then I would have the reaction force would go here, dot, 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 and this angle is the same as this one, because this angle is 90 minus this, and this angle and this angle add up to 90, so therefore this angle is the same as that one. And if it's about to slide down the plane, that means friction would act up the plane. So here I would have mu r if it's about to slide down the plane, because friction will have reached its maximum value. Now mu is 0.6, 0.6 is 3/5, so I have 3/5 of r acting up the plane. So now if I resolve in this direction, then I get that r is equal to mg cos phi. If I resolve parallel to the plane, well, it's not accelerating, it's about to, but it's not. So I have the forces up equal forces down the plane. So the force down the plane is mg sine phi, which equals the force up the plane, the frictional force, 3r over 5. And whenever you end up with something like this, something sine of the angle and something, that same something cos of the angle, then you can combine these by doing this divided by this, the one with sine in divided by the one with cos in, so that you end up with tan. So if I've got 1, 2, I'm basically going to do 2 over 1, and that will give me mg sine phi over mg cos phi. On the right hand side I get this, divided by r, so that means r ends up on the bottom. And so the r's cancel, the m's cancel, g's cancel, and I'm left with tan of the angle is 3/5. And hopefully, if I work that out, it will come to 31 degrees. So I shall do inverse tan of 3/5. And fortunately, I get this angle. So I'll just write down what I typed into the calculator. And it says show that it comes to this to 2 significant figures, so I need to show more than that, 9, 6, dot, 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 which is equal to 31 degrees to 2 significant figures. Okay, so that's the last part of the question. For that last part, it's worth 4 marks. So in this question, you've got 4 plus 5 plus 3, so altogether 9, 10, 11, 12, you've got 12 marks in total. I hope you found this solution helpful. Good luck!